class is encapsulated encapsulate classes. A class is encapsulated if its internal structure is hidden from other classes. Only methods on the class should access its implementation. Many compilers are smart enough to optimize operations into direct access to the implementation, but the programmer should not restrict the information in other classes by never reaching inside the class for data. Then hide data structure. So do not export a data structure from a method. Internal data structures are specific to a method's algorithm. If you export them, you limit flexibility to change the algorithm later. Then avoid traversing multiple links or methods. A method should have limited knowledge of object model. A method must be able to traverse link to obtain its neighbors and must be able to call operations on them, but it should not traverse a second link from the neighbor to a third class because the second link is not directly visible to it. Instead, call an operation on neighbor object to traverse the operation. If the association network changes, the operation method can be rewritten without changing call. Similarly, avoid applying a second operation to the result of an operation call unless the class of the result is already known as attribute, argument, or neighbor or the result class to perform combined operations itself. The principles in this paragraph is the principles in this paragraph were proposed in Levren in 1989, known as Law of Demeter. Then the next extensibility case is avoid case statement and on object type. Use methods instead. Case statements should be user one test internal attributes of an object but should not be used to select behavior based on object type. Dispatching operations based on object type is the whole point of methods. Do not circumvent them. Distinguish public and private operations. Public operations are visible outside a class and have published interfaces. Once a public operation is used by other classes, it is costly to change its interface. So public operations should be carefully defined. Private operations are internal to a class. They are used to help implement public operations. Private operations can be deleted or their interfaces can be changed to modify the implementation of the class with impact limited to other methods to the class. So why there is a classification between public and private operations? There is no need to bother the user of a class with internal details. Private methods just confuse the external use user of the class. Since Private methods depend on internal implementation details. The method designer may change the number of types of the arguments if the implementation changes. Private methods may rely Private methods add modularity. Internal details of the method only affect methods on the class, not other methods. Private methods may rely on preconditions or state information created by other methods in a class. Applied out of context, a private operation may calculate incorrect results or cause the object to fail. Similarly, attributes and associations should be classified as public or private. In addition, public attributes and associations may be classified as read only or writable outside the owner class. Then next part is robustness. You should strive for efficiency in writing methods, but not at expense of robustness. A method is robust if it is not fail, even if it receives improper parameters. Robustness against internal bugs may be trade off against efficiency. Robustness against user errors should never be sacrificed. Then protect against errors. Software software should protect itself against incorrect input. User input should never cause a crash. Any method that accepts user input must validate input that should cause trouble. The method designer must consider two kinds of error conditions. First, user errors are identified during analysis and report on conditions that exist in the problem domain. For example, an ATM application should report or process errors about ATM card, scanner, and communication lines. The response to these errors the part of analysis. On the other hand, low-level errors concern programming aspects of a method. The low-level errors include operating system errors such as memory allocation errors or file input-output errors and hardware faults. Your program should check for these errors and at least try to die gracefully if nothing else is possible. So, try to guard against programming bugs as well as possible and give good diagnostic information even if fatal bugs occur. During development, it is often worthwhile to insert internal assertions into the code to uncover bugs, even though the checks will be removed for efficiency in the production version. A strongly typed object oriented language provides greater protection against type mismatches, but assertions can be manually inserted in any language. Optimize offer the program runs. Do not optimize a program until you get it working. Often programmers spend too much effort trying to improve portions of trying to improve the portions, then optimize after the program runs. Don't optimize a program until you get it working. Often programmers spend too much effort trying to improve portions of code that are infrequently executed. Measure the performance within the program before optimizing it. You may be surprised to find that most parts consumes little of total time. Study your application to learn what measures are important, such as worst case times and operation frequencies. If an operation may be implemented in more than one way, assess the trade-off the alternative as they relate to memory, speed, and simplicity of implementation. In general, avoid optimizing more of the program than you have to as optimization compromises extensibility, reusability, and understandability. If methods are properly encapsulated, they can be replaced with optimized versions without affecting the rest of the program. So, how can you validate the arguments? The external operations, these available to users of the class, must rigorously check their arguments to prevent failure, but internal methods may assume their arguments are valid for efficiency reasons. Public methods must take more care to check the validity of arguments because external users are more likely to validate restrictions on arguments. Internal or private methods can often assume preconditions since the implementer has together control and can rely on the public method that call them for error checking. Do not include arguments that cannot be validated. For example, the infamous scanf function in Unix reads the line of input into internal buffer without checking the size of buffer. This loophole has been exploited to write virus programs that force a buffer overflow in system software and that did not validate its argument. Do not write or use operations whose arguments cannot be validated. So avoid predefined limit. When possible, use dynamic memory allocation to create data structures that do not have predefined limits. During design, it is difficult to predict the maximum capacity expected of data structure in an application. So, do not set any limit. The fixed limit on symbol table entries, usernames, file names, computer compiler entries, and other things should be long over. Most object-oriented languages have excellent dynamic memory allocation facilities. Instrument the program for debugging and performance monitoring. Just as hardware circuit designer instrument an IC board with test points, you should instrument your code for debugging, statistics, and performance. The level of debugging that you must build your code for debugging, statistics, and performance. The level of debugging that you must build into your debugging that you must build your code depends on programming environment presented by the language. In Smalltalk, for example, a class browser allows a developer to explore the class hierarchy, displaying attributes and code for methods. An inspector let us the user interrupt execution and print the internal state of the instance. If your implementation language does not have similar capabilities, then you can provide print methods for each class. So these methods can be accessed from also you can add debug statements to the methods. These debug statements are conditionally executed depending on instance variable that contains the debug label. You can print a message on entry or exit and selectively print input or output values. Adding code to gather statistics will help you understand the behavior of your class. Some operating systems, such as Unix and virtual machine systems, offer tools to create execution profiles of an application. Typically, these tools report the number of times each method was called and the amount of processor time spent in each method. If your system does not have comparable tools, you can instrument your code for gathering statistics much like for debugging. Next, programming in the large. Programming in the large refers to writing large, complex programs with the teams of programmers. Human communication becomes paramount on such projects and requires proper software engineering practices. The following guidelines should be observed. First, do not prematurely begin programming. It is important to first complete the generic thought process before comforting the quirk of an implementation target. All software development methodologies emphasize the importance of first designing, then coding. Keep methods understandable. A method is understandable if someone other than the creator of method can understand the code as well as creator after first time lapse. Keeping methods small and coherent helps to the accomplish these. Methods are readable. Meaningful variable names increase the readability. Typing a few extra characters is cheaper than the misunderstanding that can come later when another programmer tries to decipher your valuable names. Check the readability of your methods by running them through spelling checker. Avoid abbreviations that may confuse other programmers. Use temporary variables instead of deeply nested expressions. Do not use the two different purposes within methods even if their uses does not does a cheap anyway. Use exactly names as in the object model. The choice of names used within a procedure additional name for implementation reasons, and this is a fine, but uniformity of names where the carry forward should be preserved. This practice improves traceability, document, and understandability of the software as a whole. Then choose names carefully. Make sure your names accurately describe the operations, classes, and attributes they label. Follow a uniform pattern in making up names. For example, you might use the pattern as a verb object in making up operation names such as add element or draw highlight. Be sure to define first being used frequently. For example, you want to distinguish between copy and deep copy or between new and create. Many object oriented languages automatically build method names from the class and the operation. Do not use the same operation names for semantically different operations. all classes that use the same name should have the same origin class and the same signature. For example, in case of class circle method is area. In case of class rectangle method is area. But in case of matrix class method is invert matrix, that is this is not figure. In case of class figure method is invert, that is turn figure upside to down. This method is not good. So method names select carefully. Then programming guidelines. Project teams should use programming guidelines available in their organizations. If guidelines do not exist, then the software team should create guidelines that address issues such as the form of valuable names, identification style for control structures, method documentation, that is headers, and inline documentation. Then package modules and classes, the group classes with similar function as a module. Suppose in case of graphics, there are modules like plotting a graph, geometry, windows, animation. So we will see the related classes regarding these modules. Plotting graph regarding graph should be a line, bar chart, or pie chart. Then in case of geometry, there are different shapes such as polygons, maybe triangle, rectangle, that is square, pentagon, hexagon, that is polygon. Then in case of circle, ellipse and circle. Then windows, in case of windows, menus, buttons, toggles, panels. In case of animation, scenes, cues, keyframes. So these are the programming guidelines regarding the module and the classes. So document classes and methods. The documentation of method describes its purpose, function, context, inputs and outputs, as well as any assumptions and preconditions about state of the object. You should describe the algorithm, including why it was selected. Internal comments within the method should describe major steps. So publish the specification. The specification is contract between procedure and consumer of the class, producer and consumer of the class. Once specification is written, the producer cannot break the contract. For doing so would affect the consumer. The specification only contains declarations. The user of a method should be able to use a method just by looking at the specification. Some languages such as Ada, C++ support the separation of specification and implementation. Online online descriptions of the class and its features helps promote the correct use of the class. And each operations should also be documented itself, giving its origin, generic meaning, telling what each subclass must to do implement the operation, and what related methods are needed by the subclass. So this is the class description. In case of circle, class name is circle. Description. So ellipse, whose major axis and minor axis are equal. So superclass of this circle is ellipse. And property of that ellipse, major axis and minor axis are equal. So which are public methods and public attributes as well as private methods and private attributes. So we'll see first public attribute. So each circle or each ellipse have its center and radius. So center, that is the location of its center point, and the radius, it is a real, it's a radius. These are the attributes. Then what are the public methods? That is a draw circle in window. Then intersect line. So tangent to line or intersection of the line to the circle. So set of points, find where the intersection of lines to intersection of line and circle. So there may be 3 points. Intersection through only one point, intersection through 0 point, intersection of line and circle may be the points 0, maybe the point 1, maybe the point 2. Then area. Then this method calculates the area of circle. Then perimeter. This method calculates the circumference of circle. And there is no private method. So what is method description? So method description, method circle. So intersect line. So it has set of points. So given circle and line finds intersection and returns a set of points 0 to 2. The point may be 0, the point may be 1, the point may be 2. If there are three different lines, then three different conditions. If the line is in tangent to circle, then it must be a single point. So circle should be intersected with the line. This is the input, and the line should be intersected with the circle. This is again input. Then what is the output? A set of intersection points, and the set may contain 0, 1 or 2 points. So there is no side effects. And what error may occur? If the figures do not intersect, line and circle do not intersect, then returns an empty set. If the line is tangent to the circle, returns a tangent point. If the circle's radius is 0, then it returns a single point, and its point is lies on that line, and that must be the center of a circle. Then which operations we have done? That operations description. First operation, intersect a line and set of points. So origin class is geometric figure, and description of that class is returns a set of intersection points between the object and the line. The set of points may be 0, 1 or more points, and each tangent point only appears one. If the line is collinear with the line segment in the figure, the only two endpoints of the segments are included. Then what is the status? Abstract operation in origin class must be overridden. What are the inputs? Figure to be intersected with line and line to be intersected with circle. And what is expected output? A set of intersection points. A set may contain 0 or points, and there is a no side effect, but some errors may occur if the figure does not intersect. Returns empty set. If the line is collinear with line segment in the figure, then The set includes only the endpoints of the segment, and if the figure is an area, then boundary should be used. Then what are the object oriented language features? Object oriented languages vary in their support of advanced object oriented concepts. There is no single language that matches all styles and meets all the needs. In- Interpreted languages are useful for rapid prototyping but may not be adequate if you have string timing constraints. There is no point in building your own class library if the language provides one with suitable classes for your design. If you want extra compile time error checking, use strongly typed languages. For extra compile time error checking, there is a strongly typed languages. If memory usage is convoluted in your application, consider languages which provide automatic garbage collection. If you require persistent data accessible by multiple users, you may want to consider an object oriented database unless the language is exceptionally clumsy to use. Syntax should be a minor consideration. Syntax should be the minor considerations. So object oriented language features such as these features: multiple inheritance, class library, efficiency, strong typing versus weak typing, memory management, encapsulation, packaging, development environment, metadata, parameterized classes, assertions and constraints, and data persistence. We'll see in detail one by one. So first is multiple inheritance. You studied in C++, Java, .NET, so many languages you have used multiple inheritance. Many others. Okay, if the language you select support multiple inheritance, there is a direct translation from your design to implementation. Multiple inheritance introduces the possibility of conflict among attribute and operation names. A class could have more than one ancestor, that is superclass. A class which have more than one superclasses with the same attributes. There are several approaches that languages take to solving the problem. For example, the FL compiler rejects program with such classes. Clause, on the other hand, has protocol for resolving them. In any case, we strongly recommended that you avoid such conflicts. Relying on the compiler to resolve conflicts is a matter of poor style because it damages extensibility and can lead the confusion. Then second is class library. Most object oriented languages include a library of useful generic classes which may be used as is or customized to meet a specific need through creation of subclasses. The availability of a class library means that many components need not be re-implemented by programmer. The most useful kinds of classes implement general purpose data structures such as sets, dynamic arrays, lists, queues, stacks, dictionaries, trees, and so forth. These classes, often referred to as container classes, serve as framework for organizing collections of other objects. Classes implementing various kinds of associations should also be available in class library. More complete class libraries might include device independent abstractions of interface classes such as streams, input devices, display devices, and file devices, or concurrent processes. A separate library of user interface classes for use of one or more windowing system is useful. As a graphic library, support for string manipulation is needed by most programmers. Then third is efficiency. Each class has a structure containing methods accessible by object of the class. A pointer to each method is stored at a known location with the structure. A pointer to a method structure for the class is stored in each object. Runtime method resolution is performed by retrieving the method structure and indexing by the known offset of the method. This technique cannot be used in new methods can be created at runtime or if the name of method can be constructed at runtime because the offset cannot be pre-computed or structure cannot be pre-computed. The language system can further optimize method resolution to use dynamic lookup only where it is needed. A large percentage of method call in a typical application can be statically bound by compiler if it is provided with enough information. So there are two ways the compiler can acquire this information. First way for the programmer to declare which operations may be overridden and thus limiting dynamic bonding or binding to only those functions. Virtual functions of the clause and the generic functions of clause reflect this approach. The other approach is to provide a final optimization pass that analyzes the application as a whole, decides what methods are not overridden, and then recompiles the application taking advantage of these information. This approach is adopted by IFA language system. Note that the declaration of types for variables allows the compiler to be much more precise and its determination of which method calls can be optimized. Then fourth, strong typing versus weak typing. Object oriented languages vary greatly in their approach to typing. The term refers whether each variable and attribute value is merely known as object, that is weak typing, or may be declared precisely as belonging to a particular class, one of its descendants. It is a strong typing. For example, the attribute radius in case of class. The attribute radius is declared to be type of length. Small talk is weakly typed language. All variables in Smalltalk are object of unspecified class. EFL, DSM, Objective C and C++ are strongly typed languages. Then close and Objective C's support strong typing but do not require its use. A variable that ref- references an object may optionally be declared, and the compiler will check usually of that variable. Then hybrid languages such as DSM, C++, and Objective-C even permit the attributes to assume a value which is not an object but rather is an underlying C language type, permitting non-object values increases efficiency of common operations such as arithmetic. At the some cost is uniformity of the reference. Then strong typing in a language serves two purposes. Strong typing provides active support to the programmer in detecting mismatched method arguments and assignment statements. Strong typing also increases opportunities for optimization. The compiler can detect when a general purpose operation can be replaced by a specific function call. No power is lost by the use of strong typing. The programmer can always declare everything to be of class object to get the same effect as weak typing. Although weak typing is flexible and powerful, it permits dangerous coding practices. Modern programming language theory has been evolving in the direction of strong type checking. Much of the advantages is programming language theory have derived from restricting the programmer's ability to perform dangerous operations. Most few languages support strong typing. The premise be- behind strong typing is that it is easier to detect and correct software bugs and the compile time rather than the runtime. Strong typing improves the reliability of delivered software. Then next is memory management. The freedom with which object can be created and accessed causes a problem when memory space must be reclaimed. Most object-oriented languages allocate memory from the heap rather than using fixed blocks of global memory or a stack. A dynamic memory allocation system can run out of memory unless the objects that are no longer needed are deallocated. The principal problem lies in determining when an object is not needed. or can no longer be accessed. The severity of the problem depends on the type of the application and the memory architecture. Many programs that have access to an to a large amount of virtual memory can simply ignore the problem. On the other hand, a highly interactive application expected to run indefinitely must consider memory management no matter how large the available memory space. So there are two approaches to memory management. Either it is done automatically by a runtime system of the language, or it is done explicitly by deallocation statements written by the programmer. The preferred approach, automatic memory management, relieves the programmer of the responsibility of deciding when to deallocate memory and avoids the risk of dangling object references that explicit deallocation vulnerable vulnerable to. However, users are understandably dissatisfied with some garbage collection schemes that result in long passes at unpredictable points during execution. Incremental garbage collection schemes avoid long delays but impose a higher average cost. Improved garbage collection algorithms offer some hope in this area. Then, Close and Smalltalk offers a fully automatic garbage collection. C++ requires programmer to deallocated unneeded objects, but C++ language allows the programmer to define destructor function for deallocation memory of objects which are not needed currently, which are called automatically when the variable goes out of scope. This gives a programmer a convenient way of organizing and invoking explicit storage deallocation, but is not a garbage collector. Dynamically allocated objects must be explicitly deallocated by delete operator. Explicit deallocation runs in a dual risk of deallocating objects that are still referenced and failing to deallocate objects that are inaccessible, but it is not impose any additional time or memory cost in the program. Then next part is encapsulation. It is also known as information hiding. So consists of separating the protocol, the external aspects of an object that are accessible to other objects from the internal implementation details of the object which are overhidden from other objects. Encapsulation prevents a program from becoming so interlaced that a small change is a massive ripple effects. You can change the implementation of a class without affecting its clients. You may want to change the implementation of an object in order to improve performance, fix a bug, consolidate code, or port it to a different system. Encapsulation is not unique the, to the object-oriented language, but the ability to combine data structure and behavior in a single entity makes encapsulation cleaner and more powerful than in conventional languages that separate data structure and behavior. Languages differ greatly in the degree to which the class boundary is enforced. One way that encapsulation can be violated occurs when code associated with one class directly access the attributes of other class. Direct access makes assumptions about the storage format and the location of the data. These implementation details should be hidden within a class. For example, an attribute an attribute value may actually be computed from the other information. The proper way to access an attribute for other object is to ask for it by invoking an operation to be object rather than simply taking it. Many languages such as Smalltalk forbid direct access to the attributes of other objects or such as C++ permits attributes to be declared either public or private. FL provides perhaps the finest control of encapsulation through the export statement which lists attributes that may be read and operations that may be executed. The C++ plain declaration allows limited loosening of encapsulation for access by specified classes or functions. Encapsulation can be violated through careless use of inheritance. A subclass inherits the attributes of its superclass, but if the method of superclass directly accesses the subclass attribute method of subclass directly access superclass attributes, the encapsulation of superclass is defeated. The clause OWLFL and C++ permits a class to restrict its visibility from its subclasses. There are arguments in favor of allowing a class to access its superclasses, but the cost is tight binding between the classes. Often it is useful to write some private operations that are for internal use only by other methods of the same class. It is desirable to restrict the visibility of the operations so that other classes cannot use them. It is often necessary to allow subclasses to access these internal operations, so a simple distinguish between public and private is not accessible. Some languages permit a third level of access to subclasses such as C++ protected declaration. The next is packaging. The class is not an adequate structure construct for a large system. Most object-oriented languages lack partitioning mechanism for controlling visibility between classes. We have suggested the use of modules containing classes as a structuring mechanism during analysis. A related problem is that object-oriented languages typically require that the names of classes must be unique. Often, this is not a case when two or more i- applications are that were developed independently are combined. For example, two designers working independently might define different versions of class called symbol with different operations and semantics. The problem is similar to the name classes in blocked structured languages. So in the Ada language, the close repacking construct provide the means of the structure a system into separate components with their own namespaces. In Ada, names declared in the specification of packages are not visible outside the package unless explicitly requested, allowing control of both the namespace and inter-package dependencies. Entities that are known by one name outside the package can be renamed within. Packages may be nested, allowing an entire subsystem to encapsulated within a well-defined interface. Object-oriented languages would benefit by addition of packaging capability, in particular the ability to nest the packaging components of a system allows better control of visibility. Then development environment, the tools that are available for browsing and editing a resource code, compilation, debugging, system integration, and testing have big effect of your productivity. Support tools are especially important in object-oriented languages because of the difficulty of managing inherited and dynamically bound features in a large system. A browser allows you to explore the source code in a structured way, asking what classes are present and what operations are defined for each class. The compiler or interpreter is the most important implementation tool. Whether the language is interpreted, compiled, or translated, whether the language is interpreted, compiled, or translated affect the speed with which you can make small changes and test their effect. An interpreter allows more flexible debugging. Interpreted systems such as Smalltalk and Lisp allow an executing program to be stopped, edited by correct a debug and resumed. Objective-C offers an optional interpreter in addition to the compiler. So some compilers translate object-oriented language to an intermediate language such as a C language, which is then compiled. The C++ language was first implemented by translation into C, but the true compilers are now available. Translation may pose problems for symbolic debuggers. because they do not understand the original object oriented code. In evaluating, the debugger find out whether it shows you original object oriented source code or the intermediate source code, which may be hard to read. The debugger should be able to inspect attribute values and evaluate object-oriented expressions. The tools for system binding and change control are essential for large projects but are also valuable for individual programmers. Consider whether the proposed language provides them or integrates smoothly with existing tools. System rebuilding can consume much time if the simple change in one module requires that client modules must be recompiled as well. Try to determine what kinds of changes trigger recompilation of clients. Experience has shown that the use of conventional building tools such as Unix Make is too crude for many purposes. Finer gra- Finer grained development environment are needed but are only recently available. Next is metadata, that is a data about data. Metadata that is present at runtime allows an application to reason about the possibly even changes its own structure and capabilities, including the operations and object support, the attributes it possesses, or the types of attributes. There are also more conventional uses of metadata, such as writing a generic procedure that prints or saves any object using the attribute names and types. Languages containing explicit class descriptor objects such as Smalltalk and DSM contain runtime metadata about the classes, and a class object acts as a template for creation of new instances. The class may also contain description of the attributes and the operations such as name, type, or arguments. For example, complex number, which have two parts, a real part and imaginary part, so each of which are represented by 32-bit floating point number. Of course, a designer of system knows the metadata, so in principle, these data could be embedded in the code. But if design changes, all the code that depend on embedded data will be become invalid. The use of metadata at runtime rather than at compile time allows the construction of extensible systems with generic procedures and abstract classes that are reusable in unforeseen applications. Metadata also can be used to support data persistence or by programming support tools such as debuggers, browsers, and inspectors. Then next is parameterized classes. Parameterized classes or generic classes allows a parameterized template to be written that can be applied in several classes that differ only in the types of parameters. For example, a generic list Class can be instantiated as a list of points or list of integers. The generic add elements method on the list implicitly depend on the type of element. Local variables within the method have a generic type that depend on the instance. Parameterized classes are present in Ada language and in FL. Parameterized template have been proposed for C++. Then assertion and constraints. Assertions and constraints improve the odds that the behavior of the class matches and expectations of the clients. We can do this informally by writing a natural language description of the desired behavior. But how can we be sure that the description will be understood in the same way or even read by another programmer who wants to use the class? Usually, there are few critical assumptions about the behavior of class. Operations or methods that can be expressed mathematically. These assumptions make these assumptions take the form of assertions that must be true at particular points during executions, such as preconditions and postconditions, and constraints that must be maintained or invariants that must always be true. Assertions should also be written into the software in a form that can be optionally compiled and automatically checked at runtime. While these techniques can be used in many languages, it is particularly well supported in the FL language. So constraints can be more than simply conditions to be tested. They can be viewed as a way of expressing declaratively what might otherwise have to be written as procedural code. A language system could understood a language system could understand constraints that are declared and ensure that they remain true by taking the action at runtime to maintain the constraints. The Prolog logic programming language has such capabilities. It would not surprising to see such constraint maintenance systems become widely available under object-oriented languages. And last point is data persistence. All computer programmers operate on data. If you require data that persist beyond the lifetime of a single program execution, then you will need to use permanent data store. There are various reasons for wanting persistence data. Persistence data may provide the easiest mechanism for passing data from one program to another program. Persistent data allows the same program to resume processing at a later date. Data stores are often useful for historical or archival purposes. There are several approaches to providing persistent data services, files, special purpose hardware devices, databases, and intrinsic language support. Some new object-oriented databases are especially convenient in their data storage services. To a large extent, such an advanced object oriented databases looks like an object oriented language, except that the orthogonal property of persistence may be specified for data structures. The advantage and disadvantages of the object oriented databases relative to conventional databases. Then a next point, object diagram compiler. So in this point we will see background, problem statement, analysis, system design, object design, implementations, and which part we have learned in this object diagram compiler, that is lesson learned. Similarly, next point may be object animation. In these same points, background of animation, problem statement regarding animation, analysis regarding animation, then system design regarding animation, object design regarding animation, implementation regarding animation, and in animation which points you have studied, that is lesson learns regarding the animations. We'll see in next lectures.